When you look up at the night sky, what do you see? Stars, planets, galaxies, a tapestry of light stretched across the void. It feels complete, beautiful, infinite. But what if I told you, everything you see, every star, every galaxy, every glowing cloud of gas, makes up less than 5% of the universe? The rest, the other 95%, is invisible. It neither shines nor reflects light. It cannot be touched, held, or directly measured. And yet, it shapes the cosmos. It bends galaxies into spirals. It drives the universe to expand faster and faster. It is the hidden skeleton of reality, unseen but essential. Physicists call it dark matter and dark energy. Together, they form the double darkness that defines our universe. And here lies the mystery. We do not know what they are. We live in a universe where the vast majority of existence is hidden from us. A universe in which the visible is just the surface, and the invisible, the darkness, holds the deeper truth. This is the story of that darkness, of how we discovered it, what we think it might be, and why it matters. It is the story of a universe stranger than we ever imagined, and it begins not with answers, but with questions. The year was 1933. Astronomer Fritz Zwicky was studying a cluster of galaxies called the Coma Cluster. Through his telescope, he measured the speed of these galaxies as they orbited the cluster's center. And he noticed something strange. The galaxies were moving far too fast. By Newton's laws, they should have flown apart. The visible matter, the stars and gas, wasn't enough to hold them together. Zwicky proposed a radical idea. There must be some unseen mass, some dunkle materie as dark matter, providing the extra gravity. His colleagues largely ignored him. Zwicky was eccentric, sometimes abrasive, and the idea of invisible matter seemed absurd. Decades passed, but the universe wasn't finished whispering. In the 1970s, astronomer Vera Rubin and her collaborator Kent Ford studied how galaxies rotate. If you spin a pizza, the outer edges move slower than the center. Likewise, physicists expected stars far from a galaxy's center to orbit more slowly than those near the core. But Rubin found the opposite. The stars on the outskirts were moving just as fast as those near the center. The galaxies were spinning too quickly to be explained by visible matter alone. Something unseen, something massive, was holding them together. One by one, the whispers grew louder. Galaxy clusters, gravitational lensing, cosmic background radiation. Everywhere, the universe seemed to be saying, "There is more here than you can see." So what exactly is dark matter? First, let's be clear about what it is not. It is not ordinary matter, not the atoms that make up stars, planets, or people. It is not dark clouds of gas. We would see their effect on starlight. It is not simply black holes. There are not enough of them. Instead, dark matter is something entirely different. It interacts with gravity, but not with light. It passes through matter almost unnoticed. Imagine a ghostly substance, invisible yet everywhere. For every handful of stars you see, there are 5 handfuls of darkness holding them together. Without dark matter, galaxies would never have formed. In the early universe, gravity from normal matter alone wasn't enough to pull things together quickly enough. Dark matter provided the scaffolding, the invisible framework upon which galaxies could grow. Without dark matter, we would not be here. Physicists have proposed several candidates for what dark matter might be. WIMPs, weakly interacting massive particles. Hypothetical particles that rarely interact with normal matter, but have enough mass to explain the missing gravity. For decades, they were the leading candidate. Axions, extremely light ghost-like particles, predicted by certain extensions of the standard model of physics. Billions could pass through you every second without you ever noticing. Micros, massive compact halo objects, things like black holes or faint stars that could lurk unseen in galactic halos. Once considered promising, but now thought insufficient to explain the full effect. The truth remains unknown. Scientists build ever more sensitive detectors deep underground, shielded from cosmic rays, waiting for a single particle of dark matter to leave its mark. But so far, the detectors remain silent. The ghost will not reveal itself. If dark matter holds the universe together, dark energy pushes it apart. In the late 1990s, two teams of astronomers set out to measure how the universe's expansion was slowing down under the pull of gravity. They studied distant supernovae, exploding stars so bright they can be seen across billions of light years. To their astonishment, the supernovae appeared dimmer than expected. The galaxies were farther away than they should be. The universe wasn't slowing down, it was speeding up. Something was driving cosmic acceleration, something stronger than gravity, woven into the fabric of space itself. This something was named dark energy. Einstein once introduced a cosmological constant into his equations, a fudge factor to keep the universe static. Later, he discarded it. But with the discovery of cosmic acceleration, the cosmological constant returned. It can be interpreted as the energy of empty space, the vacuum itself seething with energy. But if so, it raises disturbing questions. Quantum physics predicts far more vacuum energy than we observe, a mismatch by a factor of 10 to the 120, the largest discrepancy in physics. It is as if nature fine-tuned the energy of the vacuum with impossible precision, allowing stars, galaxies, and life to exist. Why? We do not know. Together, dark matter and dark energy make up 95% of the cosmos. Dark matter pulls, dark energy pushes. Dark matter builds galaxies. Dark energy tears them apart. They are opposites, a cosmic tug-of-war shaping the fate of everything. If dark energy grows stronger, the universe may end in a big rip. Galaxies, stars, even atoms torn apart. If it weakens, gravity may win, pulling everything back into a big crunch. Or perhaps expansion will go on forever, leaving a cold, dark, empty cosmos. Our destiny depends on forces we cannot see. What is dark matter? What is dark energy? Perhaps dark matter is not a new particle, but a sign that our laws of gravity break down on large scales. Some physicists propose modified Newtonian dynamics, or MOND, a tweak to gravity itself. Perhaps dark energy is not constant but dynamic, a field called quintessence slowly changing over time. Perhaps the answer lies in extra dimensions, hidden from our senses, influencing the cosmos from beyond. Perhaps the two dark mysteries are not separate at all, but two sides of the same deeper reality. Speculation abounds. Proof remains elusive. Today, humanity builds ever more ambitious experiments to chase the darkness. Deep underground in mines, vast tanks of liquid xenon wait for a dark matter particle to collide. In Antarctica, neutrino detectors watch for ghostly signals from the cosmos. In space, telescopes like Euclid and the James Webb Space Telescope map the large-scale structure of the universe, searching for the fingerprints of dark energy. The Vera Rubin Observatory, named after the woman who helped prove dark matter's existence, will soon scan the entire sky, night after night, in unprecedented detail. Each experiment is a question, each silence an answer. We are listening to the universe, waiting for it to whisper back. And so we return to the most unsettling truth. 95% of the universe is invisible to us. We live in a cosmos where the known is but an island and the unknown an ocean. What does it mean that reality hides itself? That the stars we see are only the tip of the iceberg, and the vast majority lies beneath, unreachable? That means this: knowledge is always partial. Mystery is not an enemy, but a companion. The unknown is not emptiness, it is potential. The darkness is not absence, it is presence, waiting to be understood. Step outside on a clear night, look up. The stars burn against the black, but remember, the blackness itself is not empty. It is filled with invisible mass, silent energy, forces that shape all things. You cannot see them, but they are there, holding you, carrying you, defining the cosmos around you. We call them dark matter and dark energy, but perhaps dark is the wrong word. Perhaps they are not dark, but hidden, not absence, but foundation, the skeleton of the universe. And maybe that is the final lesson, that the most important things are not always the things we see. That truth often hides in the unseen, That mystery is not the end of knowledge, it is its beginning. The universe does not owe us answers, but it gives us something better, the ability to seek them. And as long as we seek, the darkness will never be empty.